Let's take a look at one more, an atomic collision, but in this case we're dealing with an elastic collision. A proton with some mass m and a lithium nucleus with some mass 7m undergo an elastic collision. Elastic collision means that kinetic energy is conserved. The kinetic energy before the collision is equal to the kinetic energy after the collision. Find the velocity of the lithium nucleus following the collision. All right, well, since this is coming straight on, we really only have to deal with one dimension here. So let's take a look. Our objects are our proton, our lithium nucleus, and a rho for total. In the momentum before and momentum after. All right, for our proton before the collision, it has a velocity of 1,000 and a mass of m, so its momentum must be 1,000 m. Lithium nucleus is just sitting there nice and happy, at rest, 0. So the total before must be 1,000 m. Now after the collision, the momentum after, well, the mass of the proton doesn't change, but it has some velocity, Vp, velocity of our proton. The lithium nucleus has some mass 7m times the velocity of L, the velocity of our lithium nucleus. So 1000 m is going to be equal to m Vp plus 7m Vl. And I can right away divide the mass out of all of that to say that 1000 equals Vp plus 7 Vl. There's one equation. Now we need to bring in that this is an elastic collision. That means that the total kinetic energy before the collision equals the total kinetic energy after the collision. And kinetic energy is 1/2 mass times velocity squared. So kinetic energy before, we have 1/2 times m times the square of its velocity. Let's call that V initial squared. That must equal the kinetic energy after. Now both of these are in motion. So that's going to be 1/2 m times Vp squared plus 1/2 our 7m, our lithium nucleus, times its speed squared. And once again, I can make a nice simplification and divide out 1/2 m out of all of those to say that V0 squared equals Vp squared plus 7 Vl squared. Two equations, two unknowns, because really we know this V0 is 1000, so V0 squared is 10 to the 6th. So 10 to the 6th equals Vp squared plus 7 Vl squared. All right, taking that a little bit further then, we can then say that 10 to the 6th, well, let's come over here first and solve for Vp. If we do this, we could say Vp equals 1000 minus 7 Vl. So over here, 10 to the 6th now equals, I'm going to replace Vp with 1000 minus 7 Vl squared plus 7 Vl squared. All right, 10 to the 6th then equals 1000 minus 7 Vl squared. That's going to be 10 to the 6th minus 7,000 Vl, minus 7,000 Vl, so that's minus 14,000 Vl plus 49 Vl squared plus our 7 Vl squared, which implies then that 56 Vl squared minus 14,000 Vl is going to equal 0. And we can factor out a Vl to say that Vl times 56 Vl minus 14,000 equals 0. So either Vl equals 0 or 56 Vl minus 14,000 equals 0. So 56 Vl minus 14,000 equals 0. Add 14,000 to both sides, divide by 56, and I can find that Vl is equal to 250 meters per second. And if VL is equal to 250 meters per second, I can take that back over here to say that VP equals 1,000 minus 7 times 250, or VP equals 1,000 minus 7 times 250 is negative 750 meters per second. So what do we have here? Velocity of our lithium nucleus, 250 meters per second. Velocity of our proton, negative 750 meters per second. Why negative? It's going in the opposite direction that it first started. It comes this way to the right, bounces off, comes back to the left with the speed of 750 meters per second to the left. Bringing in the fact that it's an elastic collision to give us one more equation, this kinetic energy before equals kinetic energy after. Hopefully this gets you started with analyzing collisions and looking at conservation of momentum. Appreciate your time. Thanks for watching Educator.com.